All right, so the title of this talk is like Gall Delenda Est, which is how to kill the mud in user space. So what's wrong with Gall? There are a lot of things wrong with Gall. And as someone once said, however, despite this worldwide shortage of bullet points, I will attempt to summarize at least some of them. So we have a category, in an attempt to preserve our bullet points, we will divide our issues into categories. So the first one is transactionality. So best instance of this is foreign key integrity. If you have two Gall agents that both share the same names, then keeping those names in sync is a huge pain in the ass. So this is the entirety of what motivated the groups 1 to groups 2 rewrite was we had way too much of this shit. We still have some of it, but it's in a more manageable and cohesive way. At one point in early in groups 1, I wrote an entire it was 700 lines of Gall agent to just scry out the foreign key dependencies and check which ones were still valid and then clean up the ones that were invalid. And of course this broke every time you changed the API. It sucked. It's bad, and it's a problem if Urbit is to be considered a database. What is table stakes for a database? It's well, you can join things on foreign keys. We need to fix this. Breach handling is another point at which we break this idea of transactionality. There's no if you're subscribing to something and that shit breaches, you have no idea how to do with that. You have to every Gall agent must manually handle their own breaches in order to maintain any kind of correctness. So a second category of issues is name-related rectification. So the first problem, obviously, is Gall just does not have meaningful referential transparency. Sure, we have the grow namespace. It's good. It works. Thank you, Ted. I appreciate that you wrote it. But it's just it's a pain in the ass to use. You have to special case everything for it. It doesn't just work, right? It's special cases which beget special cases, and it just all sucks. Subscriptions is the problem numbering here is actually by importance, not by sequentiality. But this is the problem with Gall model, with the Gall model right now. The subscription model is disgusting and an affront to everything that is good and right about Urbit. The idea that oh yeah, it's just the subscriptions just get booted and then you have to reestablish them, but not send too much data over the network, otherwise everything will just get kicked again. Awful, dog shit model. And to make things worse, the publishers are just implicitly aware of the subscribers, which means you can't scale. Namespace collisions. So as you know, every Gall agent is is addressed by a flat pat TAS. It's just a string. And so it's well, I want to write my own chat. I don't want to have to deal with certain other companies' chats. I would like to write my own chat. I want to use the chat name. I don't want to have to be chat, hep, mine. That's lame. And it's and the other thing here is this is now this kind of implied when apps build on other apps that oh, I expect the app that is installed at chat, I expect that to be the Talon chat. If you install something else there, well then everything breaks horridly. And actually the worst one of this is if you uninstall an app and then reinstall a different app over it, then you'll try and devase incorrect state and it'll blow up hilariously. And composability. This is kind of related to the transactionality one, but not quite really. So permissioning has been hilariously a huge problem for Gall, and the root of this problem is just no granularity, right? Because the unit of address in Gall is a pat TAS name, then that's the only way in which you can you either have to like recapitulate your own naming system to like address things inside that pat.tas, which is basically what a path is, or you just have to use the pat.tas as the unit of account when you're talking about permissions. And in the general, like any kind of like system-wide affordances that you would like to create, like have to be scoped to the level of pat.tas, otherwise they just don't exist. So OTAs, they suck awfully. It's extremely, extremely, extremely hard to do. I ran like a bunch of the Talon OTAs, from 2020 to 2022, and that shit gave me nightmares, man. I hate it. And the idea that normal people will do this and put themselves through that is just a lie. Sure we have peri, but there are a finite number of peris in the world, barring genetic experimentation. But it's extremely difficult to do. And so it cannot be fixed. The OTA problem, basically there's my contention that it cannot be fixed. You should not have to upgrade types over the network. Database migrations is in Earthworld are already tricky as it is. And so imply that you can do database migrations live over an arbitrary set of ships that you don't have access to is ridiculous and nonsensical, and it cannot be done by the average programmer, which is precisely what we're trying to open up Urbit to. Kelvin shimming and backwards compatibility. So because there is no everything is referred to by a name, right? So Bane is referred to as Bane is referred to by Bane, and so if the Bane types change, you now need to upgrade your app for Zeus 410 or whatever compatibility, and if Talon decides to upgrade their app and you integrate with the Talon app, then well, you're shit out of luck, because now all your shit will fail and your subscriptions will break, and then you'll have to deal with the backlog of the stuff from the time that Talon pushed the app update and the time at which you push the update to reintegrate the Talon app correctly. So it's the fact that Kelvin shimming doesn't work is symptomatic of a larger problem, which is that the dependency chain breaks super easily. Primitives, they aren't real. Everyone was oh, we'll just write some user-space primitives. There is no such thing in Gall. The entire idea of a user-space primitive is just is fundamentally absurd in Gall, because of the way that the API is designed. And this to me, it's you talk about Urbit being composable and it's a home for all your data and all this other shit. That's just a lie if you can't write something that operates on any part of your Urbit, which you can't do right now. And that's totally unacceptable. Swapability. So this is it's kind of adjacent to the back compatibility problem, but from a different angle, which is that if Urbit is supposed to be about freedom and owning your compute, then basically if you don't like the way somebody wrote their app, you should be able to swap that out in a way that does not break compatibility, that does not introduce a whole host of edge cases for your shit. You should just be able to swap it. If you have these these pieces, you should be able to swap a piece in for another piece and have that just work and not break any other part, any other person's implementation of the fact that they're synchronizing to you or whatever. Interfaces also suck. Part of this is JSON conversion, which is just not something that Shrub directly addresses, but specifically this one, having to synchronize your state in the having to synchronize your state in the sort of React world means that you basically have to re-implement your app logic and subscribe to the diffs and then reduce those diffs over your synchronized partial app logic, which means that the app logic on the client side actually has to be probably twice as complicated as the app logic that you actually just wrote in Hoon that you would just like to interface with, right? And so like Shrub, because it has a very granular unit of address, the path in the namespace, does not have this problem. And you could, in fact, like think about writing something like GraphQL for shrubs, where it's like, oh, I just expect this shrub, like then it needs to be passed as a prop into this component. And you can do that and like genericize like all of your handling of like all of like synchronizing data in an extremely trivial way. So another problem is like no metacircularity. So like it's hard to make shrubs that make other shrubs, and so on and so forth. Like that lack of metacircularity is like a huge issue because it prevents like, any kind of like meaningful like user-supplied like programming or anything like that. If you were to do something like this, if you had Shrub but it wasn't metacircular, like you wouldn't be able to do like Excel in Shrub like so easily because like the way Excel does dependencies is the same way that like Shrub itself does dependencies. So like it just all resolves out. Wait, I found no slide. The third missing slide is like Vases, a dog shit, and should be removed. And we have a plan to remove them. I think that's it. But yeah, that's like more or less it. And then sort of like the rest of the question is like, what actually is Shrubbery? Like what have I been like rambling about for the last like 10 minutes? It's actually very simple. A shrub is a write operation, some data, and more shrubs. It's that easy. It's really not much more than that. And so like, obviously it's just a core. So it has state, pokes, kids, and depths arm. And this defines like the shrub API, right? And so this curb right. So this curb is like it's like a constraint over marks. So you have this like kind of like fundamental like polymorphism like at the like top level of the shrub. So like what this says is like pro is like short for protocol, which just means a type in the namespace, and that protocol is number. You can do like say you had a counter and that counter could fail in some like unexpected way, you could do this, right? So you can have like multiple like different kinds of marks being produced at the same shrub, but you always have to express which of the marks that you're going to have. And so the pokes, same deal. It's just a set of stuff like write operations that you like are allowed to do to this shrub. And so this only has one, which is counterdiff, which is just an increment message, I believe. Because a shrub exists at a path, you're allowed to like constrain what kind of shrubs live underneath you, right? This is like a very sort of like fundamental, it's like the way in which like shrubs nest in themselves. And so each shrub, further constrains its children, like in this like recursive way. So counter doesn't have any kids, so we'll skip over this for now, right? And then you have dependencies, which obviously like counter has no dependencies because it's just like, if something doesn't have any dependencies, then you can think of it like a kind of, it's like a database or like a file, like an active file or something like that. Like it's just, in order for it to change, you need to poke it. So the form is the thing that actually does something. So we have a bowl, which has all the goodies from the bowl goal you know and love, plus some extra shit. Eon, which is like a case, is the shrub equivalent of a case. And then the pail, which is, all right, I'm going to start the Hoon translation guide. Pail. Yeah, so you have the pale, which is this is the state of the shrub. And so you can just devase that to like get at it. So init is exactly like on init. You take the old state. You take the old state and you do something with it. Where do we go? Yeah, so we just basically is like you have to. All we're saying here is like you have to give something to init because we need to like a place to start the counting at. So poke is exactly like on poke. It takes a stud, which is basically just a mark, except it's in the namespace. This general pattern of like X, but it's in the namespace, will recur a lot. And so yeah, this is just like basically a poke, and so the only the only like mark or stud that we're accepting here is number, because wait, why is it this way? No, this is wrong. Oh, wait, no, I'm being retarded. So this is where like checking that, this is not technically necessary because it's implied by the state constraint, but like that the kind of state that we have is a number. And then we just devase the state here. And then we check that the only diff type that we have support is counterdiff, which is implied by the poke interface. And then we devase it. And then we apply it to the state here. And then it's done. And like that is like the simplest possible like shrub. It's actually a little more verbose than the like equivalent Gall shrub, like the equivalent Gall agent, but it is like it does have like more features to it, right? You have to define your like external API in a way that can be read and processed by the by the state, and so that's like how we do just data in general. But obviously, you would like to do things that are slightly more complicated than that, and so like when you want to have like different kinds of things, I think the way to do that is you have like child shrubs, and so we'll go to chat, I think. All right, yeah. So we have some like helper shit up here. So we have the state is only ever chat. And the only poke we take is chat diff. And so this is where it gets interesting. So under any arbitrary chat, so there's like 3 different ways you can address the namespace in the general. One is obviously like if you've done like interesting things with chars, you would like it's very similar, but it's like X is like just the data. Y is data and the immediate children of that shrub, and the data for that immediate children. Z is data and all of the descendants all the way to the bottom of the tree. And so when you talk about your kids, you can either talk about them in the X way, which means I don't care what my kids are. You can talk about them in the Y way, which means you're constraining your immediate children. And then you can talk about them in the Z way. It's like, I have like total sovereignty over this entire cone of the namespace. And so what this says basically is, well, we only care about our immediate children. And that the immediate children, you read this, basically this, like, and messages, bar, faz, DA thing. What that looks like is like, it looks like this. messages, any patda, right? So you now have like basically URL parameters for your shrubs, which is fun and nice. And so the left side of the pair that describes what the kid has to do and look like says that like, okay, this has to conform to the message type. I say conform and not be of the message type for reasons that will become clear later. And then the seg just says, well, we don't have to poke it. That message is free to implement other pokes if it wants, but like where we are promising like that we don't depend on the, like any of the poke behavior to the child. And so this dependency is like a trivial like example dependency, but it's like it says it's open and it's not required and it is a Boolean, a Lubian, whatever. And if the dependency for that is not online, is not yes, then we like knack all requests to change the chat, including like new messages and so on. What makes that fun is that like you can imagine like putting this chat into like a Twitch stream or something, and then like, well, if the video is live, then the chat should be live, but if the video is off, then the chat is done, it's over. So we have a poke handle, which takes a chat diff, which just, you can add a title, you can add somebody to the chat, you can delete somebody from the chat, you can message the chat, and then, yeah, they just send a custom message. Anyway, the point here is that like, we're not saying anything about what the underlying message looks like, right? We don't actually deal with messages on this layer except to like add them, and this add message arm just produces a card that makes a message, right? Which is to like create a new shrub in the namespace, right? So we can poke it, and we can have like Faz now is, hello, right? And so where this gets interesting is because we're talking about message as a vibe, as like something that can be implemented. This chat is actually like polymorphic over the message, the kinds of messages that it can have in it, right? So there's like not even this question of like, oh, I want my like Talon app, my Talon chats and my like Holium chats and my Keynote chats to all live in the same place. You can instead just like have one chat and whoever's message type somebody wants to send, you can send that, and that's fine, and it just works. And so this is also actually how we get away with dealing with OTAs in like a significant number of cases, because if you want to like change something about like the message type, so you want to add like reactions or likes or some shit to it, all you have to do is just like have a new default message type called message2 that implements the message protocol. And then you can just start adding like reactions into your chat by default, but you don't have to do these like fucked up and hairy like schema upgrades over the air, because like all of the data that was previously bound in the namespace is still bound in the namespace. It hasn't changed, and it will not change. So that's really nice. And so like, yeah, you can imagine doing like arbitrary numbers of like nonsensical things with like this idea of like implementing a message. Like you could have like notifications just be a chat type, and then like you're making a message that is like implements the message protocol, but is actually like a notification that like something happened or whatever. So it's like extreme flexibility at sort of like every level of the system, which is really nice. And so like this idea of like, oh, you just implement the thing also extends to dependencies, right? So this open dependency, it has to implement like, the ability to be read as a Boolean or like a Lubian or whatever, but it doesn't like have to be a Boolean. It could be some other thing that you can turn into and convert into like a Boolean. which is really nice. And so the other thing with dependencies is this is actually also the way in which you do like dynamic scroll requests. So we have no .cat, right? We got rid of .cat. Instead, you can just try and inject a dependency, and that will this dependency can come from anywhere in the namespace. So like if you want to like synchronize somebody else's chat and like deal with that chat in some way, you can just synchronize it, and you just inject it as a dependency, and it's there. You don't have to deal with like watchacks, facts, kicks, all of this shit. It's just you inject it as a dependency, and from the moment that the shrub wakes up, that dependency is already there, which is nice. Okay, it's like I feel like I should stop and like stop rambling and take questions that I will like cut short in like 5-10 minutes.
So
yes.
the shrub will not be there until it has all its dependencies, even if they're like way over the network?
Okay, so this is what the required flag is for. This required flag can also be expressed like a more complicated set of network constraints. You're allowed to time them out. You're allowed to like do a whole bunch of things. But like generally, and there's like I have a whole system for putting progress bars in this at some point. But yes, like basically this is like you generally don't want the blocking like I'm just going to block until I see that until I have the full shrub downloaded. In any case that will go to production, but it is a really, really convenient prototyping tool. It's like, oh, I can just block for it, and then it just works. So.
After you get the other shrub,
Yeah.
What context are you aware of, like at the point that you're at the code, right? Like,
Yeah. So like, this is what's really nice about this system is that like, other than like kids and dependencies, the shrub doesn't know anything else about the system. It knows like it knows like who you are and like where you live, but it doesn't know. It can't assume anything about anything about any part of the namespace other than the dependencies and the children.
So if you have a dependency shrub,
Yeah.
do you have access to, let's say, I assume like type information about the shrub?
Yes.
Right. Do you have, if the shrub is tracking some state, do you also have access to that?
Yeah. So this is what this is. This is like I want the state to look like this, and you can track that state. This sig here is also a set of write operations that you're allowed to do, and so this is also the way we do permissioning, right? Because the only things that you know about, can see and can poke are the dependencies and the kids, and you're always implied to have like total super user permissions over the kids. Then like dependencies is the only place that you need to handle permissions ever.
Dynamically change your dependencies, or how does that work?
Yeah, you just overwrite yourself basically with the.
Oh, okay.
Yeah. So you could do a whole thing with like, if you like for Mark's sort of like loading example, you would inject yourself with a kind of like larval shrub that like would like deal with it's basically like a loading flow, and then when you finally had that dependency, you would overwrite your shrub with the same version, but it's like you're requiring it now, and so that then you can like progress to like, okay, we actually have loaded everything. You can start showing interfaces and shit like that.
In an example where a shrub is like less of a protocol, but something more like an agent, like a Gall agent, and still is used on, like let's say, in multiple apps, right? How do you reason about the permissions in a sort of in the context of the dependencies of this new shrub that you're writing?
So like so how do you really reason about dependencies in sort of, I guess, what kind of way?
What I mean is like if it's used in other implementations,
Yeah.
How does inheritance work, right? How does like what is kind of the source of truth if it's used in multiple different places?
The source of truth for.
So this dependency
Yeah.
is like you're getting it from somewhere.
Yeah.
Right? But also, like where is the sum? Is it on your ship? Because if it's on your ship, you may use it in other applications.
Yeah.
And if it's used in other applications, that
No, so this is a great question actually. So it's like this is sort of like I said we'd solve the transactionality issues, and I mean that, and so this is a good place to like pivot into that. Okay, so like the way in which, so like each shrub is like sovereign over its entire sort of like cone of the namespace, right? So if you have some path, foo, bar, right? Anything like foo bar, decides at the end of the day what goes underneath itself, right? And so the way that we do this is that imagine foo bar pokes baz, right? And so there are two different kinds of sort of I/O in Shrubbery. And so one of them is like, so foo bar makes a call to foo bar baz, right? This is you're going down the namespace. And this is treated very fundamentally different to if foo bar makes a call to like, a different ship, or just even like 1, 2. These like downwards, like child I/O is considered differently to this like sort of uncle or like cousin or whichever familial distant relation you prefer, that kind of I/O. And so when you do child I/O and you go down the namespace, this is not like what you traditionally think of as a message pass. It's actually something more equivalent to a function call. And as a result of this, you don't get any acts when you poke your children. Instead, when the act for your child is like, you get a notification saying that, hey, you poked it, and like here is the new state, and then you can send more pokes to this. So you have like kind of like a little mini function stack inside the like operation of any like poke to the network. But what's interesting about this is that if you poke foo bar and foo bar pokes baz, and then baz crashes, then this whole operation is rolled back, right? Which allows you to like nest things inside other things and like not have any worry about like transactionality. Because it's like, so like it's actually like really trivially easy to do something like sort of like relational data style like tables here, because you have like at the root level, you have a database, and then you have like table 1, table 2, and then like, say table 2 gets poked, say like add a row to like add a row to like table 2. But that row has like a foreign key in it at like the points of table 1, and that table 1 does not have that foreign key, so it's like it's an invalid thing. So when table 2, when this rolls up to the database, the database now sees, it checks all of the like new all of the new foreign key constraints, sees that it's invalid, and then rolls the whole operation back. So it's like trivially easy to get like basically any kind of like transactionality semantics that you want, while still reusing code and reusing the I/O that you're using for that, which is really, really nice. So like, interesting use case for this is something like, for a long time, like groups 1 had like metadata store, and that shit was a nightmare because like, if the poke failed or for whatever fucking reason, like you had something retarded with it, if the poke failed, you might have like dangling entries in your metadata store, and like, something like you have dangling entries in metadata store that doesn't point at anything that actually exists. And so like with these like rollback semantics, you can like just stick the metadata store inside the thing, and then if the metadata store is invalid and the parent sees that, it can just roll back the whole transaction, which is really nice. And like you can also like provide additional, because you're rolling up to the parent, you can also provide additional transactionality constraints that the child doesn't know about, but are like implied by the parent.
But you're establishing this new path fragment that was invalid, but you may need again in the future because it's useful.
Well, so just you roll back the entire thing basically. If it's invalid, you knack the originating poke, which is always like an uncle poke, which comes from the outside, and you knack that. So the uncle I/O does in fact get acts. It does in fact get acts, and so it's like this is also nice because it generalizes the whole, like, you know, as you may know, you have depth first ordering to pokes on your own ship, but you have breadth first ordering across the network. And so this generalizes that whole idea of like, you know, what is like an asynchronous call. And it's even possible that, you know, if you had a very fancy runtime, that you could run these shrubs in different threads because they're separated by like a basically in effect a network boundary. So that's a general overview of the transactionality model. Anything else before I can start speaking about overlays?
Can you explain a little bit more depth the thing where you specify things about your kids? Where you have like the X, Y, and Z
Yeah.
methods, where like X is just about yourself.
Yeah, so X means,
Y is about your direct children, Z is about all your descendants.
yeah.
But what if I just want to say things about like my direct children, but there's like two pad elements there?
Yeah. So like direct children is not like the direct children in the sense that like, so it's like a sparse Excel, right? So it's like if you have chat, right, and you have faz chat, faz messages, faz patier, right? There's no shrub installed here, right? Which means that your immediate children is actually all of the messages.
Just by virtue of there being no shrub.
There's no shrub in the middle, right? So it's like, yeah. So it's like, what you mean by immediate children is like the shrub, like all of the shrubs that have you as their parent.
Okay, and that's not pad based, that's like shrub existence.
That's like the shrub existence check, yeah.
Yeah, I'm not sure. I still don't. Maybe I missed sort of the permissioning. Like, where does that happen?
Yeah, so the permissioning is specified but unimplemented. So it's like basically like when you decide, this is the other reason that dependencies are allowed to block, is that basically when you try and inject a dependency that you don't have permissions for, that will block and like request the user's permission, right? And so like you will only block on the permission injection if the thing that did the injection doesn't already have permissions for it. So you can just like, you know, you can pass off like I already have thing and I can pass off the same dependency to my child, which is nice. And so you don't have to like constantly nag the user for permissions. But like, yeah, it's like that's unimplemented, but it's well spec'd and we know how to do it.
Can you delay acknowledgements of inbound uncle pokes if you yourself make other customers?
No, you can't. There's like, you can, there are, we can talk about this later because it's like very sort of like in the weeds, but like there is a way in which you can get like multiple like calls to like Uncle IO to like compose and like roll back as a unit. But like in the general, that's sort of considered a different way. It requires that you like have certain constraints about stuff and other things. Yeah.
All right. Can you mess with this at all? Like, so like let's say you wanted to in the instance where you're like looking to see if you have a valid you know, child and you're like traversing the path and you're going down and you're going to revert. If you don't, can you write a hook that let's say does something with this result that you know,
No, it's like very much like either you crash or you don't. You don't get any like. You want to do that kind of like fancy nonsense. You can put like a tang, and this is what Ford does. Is like you virtualize it. You want to do error, like wrap the whole thing in error handling. Yeah. You just add a tang as like one of the options for your state type, and then like, you know, you can like handle sort of like error cases and like propagate them back up the tree. Do whatever you like.
you have a place to propagate that you have like.
Yeah, this is like the whole point of like the tang system. This is how Ford works. Is that like you just keep passing the tang. All your dependencies are either vases or tangs. If either of them are tangs and you're trying to do something with them, you just republish the tang and then propagate that up to the build output. All right, overlays. Thomas, next time can you get one with like air conditioning in this thing?
And an eraser on sleep.
All right, overlays, fun. So an overlay is a path, let's say like, so the easiest overlay is just like add. No, actually, it's not even add, it's ink. It's just increment. In the spirit of like knock, we'll do inc. And so this is some other path. You just prepend, you just weld the paths together. And so this is like whatever, so this requires, this is like basically sig if path is not like an atom, right? It's like it's just not defined, path is an atom. If it is defined, then it's just atom plus the like what we call the overlaid value. Right? And so like this is like a fun example, like just to get your head around, but like there are and so like what you can do with this basically is have transformations like over the namespace that are basically, they're well-defined and consistent. However, they may not be like an inherent, like the way you want to treat the data at the shrub level, right? So it's like, oh, well, how do I do, so like how do I do, if I have a chat app and that chat app has a React interface, well, then I want to do things like fetch the latest 20 messages, right? And so you can do this by just embedding skag as an overlay, which takes, some number, and then an overlaid path, and then this will just take the first 20 elements, the first n. This will take the first n elements of the underlying path that you specify. And this is well defined for every path in the system, right? Because the trees have an inherent ordering to them, and that ordering generally makes sense. If you want to do something different, you can also implement that as an overlay namespace. And so then you can do skag, because these things fucking compose. So it's like custom sort and then path, right? And so it's like, okay, now we have the first 20 elements, children of this path, with some arbitrarily defined sorting value that lives at this custom sort overlay.
Anonymous function.
Yeah, it's like an anonymous function that's been bound in the namespace. Because it's bound in the namespace, you can address it like anything else. And so these are quite powerful. And so to your question, you can actually, so one of the ways that I was proposing that you do something like Git actually is Git should be like an overlay. It's faz, because it's the actual checkout of a Git is it's just a function of the Git repository and whatever your active head is. So all you would do is check out and then path to Git shrub, right? And then so you can do that, and it will just work. What's nice about this actually though is that because of the way this works, you're allowed to poke through the checkout. And so this checkout overlay, this Git checkout overlay, can actually pretend to be just a regular file interface. It's okay, I take text writes, and I take hoon writes, and I understand how to translate from the checkout into the doing the naughty shit with the fucking underlying Git objects and turning that into a series of pokes such that the overlay will it will be as if the overlay was just a real shrub that implemented a file system. And so directed messaging obviously uses these prolifically. And for all purposes, these shrubs can be generally considered to be as real as any other shrub, but it's just it's a derived data.
Can you elaborate on that a bit more? Because say we have the increment, right?
Yeah.
Next to the counter you had earlier.
Yeah.
If I operate on the incremented number
Yeah.
It's like the counter.
Well, so like int obviously doesn't define any write operations.
Well, no, this is piano arithmetic in the namespace.
Yeah. But this is what I mean when I say like the Urbit namespace is as dense as the real numbers, because it's like you can, if you take like an infinitely long path, you can construct any number you'd like.
You could poke an overlay.
Yeah, you can poke.
Piano numbers, and you could do arithmetic on them by prefixing the path.
That is true.
This is
Yeah.
Gall Delenda
Wait, but does the overlay have to do like a special translation of the poke?
Yes, to the underlying, right? So like this is like defined like by the overlay. So like
Okay,
you,
so it might
so
be like-
@inc is probably like read only, right?
How do you create an overlay?
Yeah. So there is a defined. Okay, so an overlay namespace in the general case is basically this is the general. This is the like increment overlay, right? And so the way that they're defined semantically, which is fun, because this is actually not the only kind of virtual shrub that you can have. Okay, so a path, like an overlay, is defined semantically, like a virtual shrub in the general, actually, is defined semantically in terms of like, it has states, pokes, dependencies, and so this is the general character of a virtual shrub, is that it is some function over a list of paths. Right? And so obviously we can't like actually, if you want to overlay it, you're only giving it one path. And so what happens is you can instantiate this virtual shrub with all of the paths except one. So like, let's say for the like get latest chat, right? We have a get latest chat, get last messages overlay. And this might take a count dependency, just a pat UD, and it might take a the messages themselves, which is just like can just be anything. Now, how we turn this, well, what we do here is we can bind this like virtual transformation of shrubs by giving it all but one of its dependencies, right? And so it's like currying for virtual shrubs. So you basically like you give to instantiate an overlay, you give get last messages. You give it some count, and you bind that count in as a dependency, but you have one missing dependency, which is the messages and where they come from. And so where the messages come from is, well, whatever comes after this in the path. Right? And so you can and so this part of the path is where the missing message dependency comes from, and it's like dynamically instantiated depending on what path you're overlaying. And so like this is like nice and fun, but it doesn't get you like quite everything what you want, because you want another slightly different kind of virtual shrub, which is like, so this is obviously like f path, and this can only produce like a pale cage for those stuck in the prehistoric times. There is another kind of virtual shrub, which is f of some list of paths to an exal, which is a recursively nested map. It's a mapping from path to like namespace binding from an exal of pale or cages, right? And so this can't be like, you can't do the whole like, instantiate all but one of the dependencies with this, because then you ruin the like path compositionality. Like the fact that you can do overlays depends on pale and cage, like the produced item being a single item, so you can like mirror out the structure of the thing being overlaid. This is really useful for things like this must have like fully instantiated dependencies. You have to give them all of them, but it's really useful for things like sort keys and like search indexes. So you can automatically derive like a sort key, like a sorting function, or like a search index. You can automatically derive them using this. And so like it's like a kind of like the difference between this and this is like this is allowed to reconfigure and like restructure the namespace. This is not. This has to be a one-to-one mapping with the thing it's overlaying. And so like having that ability to do search indexes and sort and all that kind of shit brings us finally to feature parity with Postgres. Any focus? I think that's like most of it. Anything else is just like 3 hours and too many beer. That's like most of, I feel like, what I can cover. Any questions about overlays or questions in general? AJ?
Yeah, with this like, is it like, what are the if you wanted to try and get like the state of like, is it trivial to like get the state of the shrub and its like children like rolled up?
Yes, yes.
Thing?
So in fact, these are not just regular paths.
Right.
These are like, this has a care and a path, right? So you can like, and a care is like, is it X? Do you care about the thing, or the thing and its children, or the thing and all of its descendants? So you can like, do all kinds of fairly hairy shit with it if you're so inclined.
Because you mentioned feature parity with Postgres.
Yeah.
Like another popular database is like Firebase, which is just like a large JSON tree that you can like write to like any part of the tree, like inside any like large object, right?
Yeah.
So you can imagine like just like a key value store that only stores one property. You could also like get feature parity with that maybe by just like write a bunch of children all at once.
Yeah.
And then read.
I mean, yeah, you could do that. I'm not sure why you'd want to, but
Yeah.
yeah, you could totally do that. Mark?
Do overlays live in the same namespace as normal shrubs?
Yes. Well, so like this is like part of like this is why I ripped it out for the like first pass is that to make overlays like meaningfully real, like you need to have them sort of like be like normalized. But yes, they do live in the same namespace. It's just like you have to handle them like separately, like in like a slightly different way.
Right, okay, so we just have a namespace with not shrubs, but shrubs and overlays.
Yes. Yes.
Okay.
It's like a unified. But from the perspective of the caller, it should never leak whether you put like calling into an overlay.
Call the thing.
You just call the thing in the path and it does.
So they should all be shrubs.
Yeah, they're all shrubs, but yeah. So I call them like concrete and like virtual. They're all real.
Do they have like a fundamentally different form? Does it that
Yeah. So this poke just produces a list of cards, and so like you can't actually it has no state to modify. It can only poke its dependencies. If any of those pokes bail, the whole thing will bail out, kind of in the same way that like if any of the child pokes, because this is considered like I call this like hyperparent semantics. This is like a kind of weird, like spiritual parent, godfather, if you will, of the of all of its dependencies. So like it has that same rollback semantics as parents do.
Is there like a guiding methodology for like where you put things in the namespace?
I'm glad you asked. So this is the Shrubbery axioms. And like I would contend that like most of Shrubbery itself is like derivable from like thinking really hard about these axioms for too long. So obviously you start with like what is a shrub, and like a shrub is just a way to constrain like what are you trying to do with like shrubs and like code and applications. Like you're trying to constrain the data and the data transitions on the namespace. And like both on the namespace and anything underneath that namespace. Relocatability. So like shrubs, they like it knows and understands everything that's beneath it. It doesn't know anything about its parent. It doesn't know anything about its cousin except for what you get for independencies. And the reason we do this is you can install a shrub anywhere. If you have a fully featured chat application, you can put that in the in the documentation for your shit just if that's something that you would like to do. Like, you could put anything anywhere. That's the whole point. Well, what you get from the first two axioms is that the shrub defines its like transactionality boundary. Each shrub is its own recursive asset database. And so you can do like foreign key integrity and all that kind of nonsense. Identification. For concrete shrubs, a shrub is like the path at which that shrub lives is the primary key. Don't do things like we might have collisions here. Like have it be a primary key and specifically like an end-to-end primary key. So if you're doing like chat, like the canonical way to do chat would not be to do this bullshit with like messages. The identifier for a message is patDA. It should be like the way Talon chat does it, which is like, a vector clock of the like ship and the patDA. And then you can use the like custom sort bullshit to like, and the indices to like back out the received index. So like, don't use the namespace for sorting if that like fucks your identity model. Seperation. So like there's a fundamental like tension between like 2 and 3. And so like you basically like want to minimize the number of like sort of like circular dependencies between like cousin shrubs. It's like if you have like sibling, like if you have 2 of these and they need to like kind of be constrained by the parent in some like bizarre way that doesn't necessarily need to be polymorphic, you can like lift it up to the parent. And then so like from that general like vague nonsense, you get the more concrete version, which is like variably sized stuff goes in the namespace. Reuse functionality, pull it into a child shrub. If you want to version something, pull it also into a child shrub. If it could be, you might have different versions for a chat and for a message, then version them differently. This is an example, this is like this. Cannonicity. For any given like datum, it's like you can imagine like storing these things in the namespace in arbitrary ways. Store it once, and then like use overlays to like kind of recapitulate the kinds of ways that you would like to query the shrubs and to like provide like cuter and like more convenient access patterns and things like that. Virtuality. So it's like this is the thing. But it's like virtual bindings, restoring the implement, like you can reproject the data however you like, however the query pattern demands. And so yes, Josh, you can use this to do datomic in Urbit, and a whole bunch of other things. But that is like the general sort of like principle of the layout. I think the variably sized containers bit is the best place to start, and then just like start to feel it out. It's like you gotta rotate some shrubs before you like actually get there.
Is there a sort of recommended pattern for storing annotations on other shrubs and other bases?
Glad you asked. So like
Comments on chat messages or whatever.
So like the fundamental question for this is like the fundamental like sort of question with that is like how you would like conceive of the sort of like the transactionality boundaries and the like logical ontological structure of the data should be the way in which you lay it out in the namespace, and everything else is like secondary to that. And so like the question for like annotations is like how does that affect your like transactionality guarantees? So for example, if you write a chat application, right, you probably want like the unreads to live inside like the same transactionality boundaries as the subscriber shrub, right? Because like that's just like that is like convenient, and it's like it's closed-ended the ways in which you would like to refer to like unreads, right? But if you want to do arbitrary comments, you can kind of like you can stick that in a kind of like what I call like a semi-virtual overlay, which we can get into later. But we have like there are a bunch of like ways in which it's like planned to do this. I don't have any concrete ideas for like generalized annotations, but it's like also you can just always store a path to something. So like that's a fine way to do it for now, yeah.
Can the same shrub be virtual in some aspects and concrete in others?
It's an interesting problem, but not yet.
Well, so if the user wants to like control their notifications or their
Yeah.
emails, right? They want to sort of do some transition.
Well, I mean, like you could do, like, if you want like control of your notifications, like that's fine. You can just like take whatever notification like data structures you have, and then just like write an overlay on it, and then like read and write from that overlay. It's like that just works. But like you want to do something.
What if I want no one else to see that because this is like my own logic around my own? Like,
Yeah, and then just don't publish it.
But you have to derive the shrub from the namespace.
You have to derive the data of the shrub from the namespace, not the shrub itself.
But I can not publish the path.
Yeah, you can not publish. We have private data. Yeah, sure. Well, we haven't implemented private data, but like conceptually, it's there. Yeah.
So this like doesn't seem to be really just an application framework or whatever, right? So, I mean, I thought about how Unix, you could, everything is a file, quote unquote.
Yeah.
So, like, is that essentially the
Yeah, this is like essentially like sort of like the idea, and they're like because like everything is a file. What that means at the limit is everything has a name. And this is the true like realization of like, oh, if you can address it in a single way, then like that's real. Files are not real. Files are like seek, read, whatever. Don't care. Like a file like at the limit is a name, and that's what matters about the Unix philosophy.
Can you talk a bit more about the security model? Because I know you have like interesting ideas there.
Yeah. So the security model is, in a sense, for like you have like two different notions of security model. Like one is for like the idea of a root shrub, which is like it's like BYO security modeling, and we give you these tiny little like retarded primitives. So think like the way that the like encrypted remote scry works now, where it's like okay, you either have like a key, or like you either have a key to access something, or you don't, and that's it. And then like Gall has to build its own like key exchange primitives on top of that. Yeah, so like the root shrub will provide like key exchange primitives and all that kind of nonsense. And so like basically the way it's more or less like going to work, at least initially for the first root shrub that we write, I think is like something along the lines of like, well, you'll just have like security, faz, chum, pat p, faz, shut, which is just a unique key ID, and faz open, which is just nothing because it's it can go anywhere. And so like, you can just like basically like any shrub, like those like any shrub can like optionally like provide one, or you can like defer the parent or whatever. It's like still haven't quite like script those semantics out, but like because this is not going in the root shrub layer, you don't have to get it right first try. So like there are some I welcome questions, comments on like security layers and things like that.
I mean, you said root shrub just now, but I don't think you've explained.
Oh yes. Yeah, so the idea of a root shrub comes from like the sort of, it comes out of a conversation that I had with like about sort of like, well, what if you had like an AI agent like at some part of your namespace, and so like if the like AI has like a bunch of has its own sort of like a little mini virtual like universe of a shrub, and like it has its own tools and its own data and its own bookkeeping, and like it would like to be able to like use the shrub the same way the user would. And so like basically how it works is that like you can define the idea of like a root shrub or just a root, which defines basically it's like a kernel vein, except it can't break referential transparency. And so it's like what Shrubbery is sort of at the limit when the root shrub stuff is done is not just a user space model, but it's like it's a meta user space model for building user space models. And so something that falls interestingly out of this is something like Aqua, right? Is its own root shrub where like you have faz Aqua. There's a root here that is like a sort of network emulation root. And then you have, each of the ships in your aqua fleet. And then this is the same root shrub that lives at your own Vase, right? So you can get like metacircular, like Urbits in Urbits, however you like. And so like, you can do things with this around like having like different, like you can sort of do different things with like the way you specify and constrain your child, like your children, is sort of like, that is a like root shrub level detail and not a shrub runner level detail. So it's like a root shrub could change that. It could be like less aggressive. It could be more autistic. Yeah, there's like a whole variety of ways in which you could. But the important part of root shrubs is that you get like full metacircularity if you decide that you want or need that.
So it's not possible for normal shrubs to refer for their behavior to like a parent shrub. The thing you're doing there, where aqua has some implementation, and it says, oh yeah, I have children. A child would not be able to say, oh, you're like poking me, well, I'll poke aqua and then have that do the behavior.
Yeah. So like a regular like children can't do things like intercept the call stack, add logging functionality, do a whole bunch of like stuff. Like you could do a whole thing with like sort of like does not respond if you don't have a poke and you try and poke it there, then you could redirect it to some fallback shrub or something like that. The root shrub can manipulate the call stack in arbitrary ways and do like weird nonsense.
What happens when the data at your dependencies change?
That's a great question, because this is in the entirety of like how we do subscriptions, right? Is that like where's the message sub? Yeah. Cool. Right. So basically, what happens is that if you have a dependency and it changes, and that you specify that you accept the rely poke, then you'll be woken up with a rely anytime any of them change. And that rely poke will have inside it a diff from the last time you were woken up, what that state looked like, to the current state. So you can
How does it get the diff?
the diff. Well, it's just like trivial because we have like an unbelievable amount of like case tracking in this kind of stuff. So you just save the case at which it like was last woken up at. When you get a new one, you just
When you say diff, you mean you just get the old and the new one?
what? You get the new one. Yeah. It's a part. It's like an exile diff. It's file. Yeah. So it's just a like exile diff, right? It's like okay, this path is new, this path is gone, this path has changed. And yeah, so this is what the message publisher does. Message subscriber does is just like takes the messages and republishes them to some namespace. And then the other thing is like is this new basically like dead tracking, which is not actually used anywhere, but it does work. Is that like you can accept a dead poke, which will inform you that one of your subscriptions has died, or one of your dependencies has died. And so like, because you can consider breaching is just deleting the root shrub, you now have breach handling for the entire system. Hold on. So like, yeah, it's just like you get a dead. If you get a dead and the dependency is required, and you don't re-inject yourself with a newly valid dependency, then that shrub is put into like stasis, basically. It won't accept new pokes. Like it basically is considered like kind of suspended. Data's still there. It just like it will refuse to like be poked.
Right, so you can say like, oh, yeah, my ship's kind of messed up, but I don't want to like breach everything. I'll just breach this big channel that I'm hosting or something like that.
Yes, exactly. So you can breach any arbitrary. It's the same thing as deleting, right? Like you're breaching any arbitrary part of it.
Like we don't need to be full breaching ships. We just breach our.
Yeah, as long as you still have the case numbers and you can like pick back up where you left off. You don't like you can just if something's messed up, you can just breach that entire subsection of the namespace and like reinstantiate it.
So I'm thinking about some of these root shrubs in terms of like, 'cause it seems like this might be a way that you could add like logging. Right?
Yes. This is like
But could
you
you
have.
compose them too? I'm wondering. It's like
Could you?
add logging, like, so for example, if you wanted to have like right? But an aqua shrub with logging in it.
Yeah.
Is there any way that you could compose it, or do you just have to have it?
Well, it's like that every shrub defines its own like methods of compositionality. Like we deliberately give you the bare minimum so that it's like you can Kelvin version just the bare minimum, and then everything else is sort of like up in the air. There's only like sort of 4 privileged entities in the like shrub runner system. It's like types, semantics on types, up like shrubs, semantics on shrubs. That's it.
I have another question. You described root shrubs as a way of implementing shrub-like systems.
Yeah.
Along those lines.
Yeah.
Have you thought about what it would be like, or what it would take, or if it's even possible to have a root shrub that is essentially a Gall emulator?
No, it's like it's actually fairly easy, because like, yeah, you could just like you would just be able to like do it. I think like it's like you just copy.
You're going to need to add a little bit more.
Well, yeah, but like on some level, it's like what's it called? The only issue with like Gall is that like you have to close a lot of the like the fake referential transparency issues in Gall, right? Because like .ket is not actually referentially transparent ever, because you can read something, then you can poke that thing, and then like when you get the ACK in the same poke, it'll have the same date, but you'll scrape for it again, it'll change. So like it's a little what? Oh, the ticks do solve this, I guess, yeah, but ticks do solve this, but like I don't know, it's kind of insane to imagine like republishing the namespace on every tick. It's like a
Ticks may not solve this for shrub,
yeah.
but that depends on how you schedule.
Yeah. But I feel like you could do something. You could do a Gall-like emulator. And I'm not saying it would be trivial, but like it doesn't strike me that hard if you can work out how to like embed it.
All had things in it that couldn't fit.
Yeah. So like the bulk of the work is just re-implementing Gall's idiosyncrasies in.
Yeah, basically.
Do you reckon that's a path for keeping Gall around for longer than we want to keep the vein proper around?
Yeah, it might be. Yeah. I mean, we also have like veins themselves are wrapped in shrubs, so like you never call into a vein directly. It's all like indirected through a shrub, which allows you to do kernel space permissioning. Right? It's just like if you want to talk to a shrub, like a vein, you have to inject its corresponding shrub as a dependency. So you now have like kernel space permissioning, and so Kelvin shims, because those are all like structurally, those are all like structurally typed. So you're depending on I would like to be injected with a vein for 10 dependency, and then like you can keep that vein for tension around for as long as you like, and just